Hey, I forgot to mention in the first recording that one of these three questions, question 1, 2, or 3, will be on your actual test, but it won't count against you. Like these are final exam questions, but just to get you thinking about them now, I'll put one at the end of your test. And if you get it completely wrong or don't answer it, it's not going to hurt you, not going to count points off of your test. However, if you nail the question, if you get it right, you can get 10 extra points on that test. And believe you me, we all need extra points on biology 142 exams. Okay, please describe the negative feedback regulation of blood calcium levels. Well, here now we're going to be describing blood calcium levels between a certain range, 9 and 11 milligrams per deciliter. And we want to make sure if the blood calcium levels are going up, how does the body make the blood calcium levels go down? And if the blood calcium levels go down, how does the body make it go up? And so up and down we go. That's a negative feedback of calcium levels. And what I want to know is, how do we do this? How does your body do this? When we did the negative feedback of thyroid hormone, it was basically the hormone levels itself kicked off the system. Here, we're not looking at a hormone that we're trying to like before when we did the last question, it was thyroid hormone that was going up and down, right? Now we're doing blood calcium levels. So keep that in mind. So first of all, you know, in your body, you have one place that you can store calcium, and that would be one great place would be the bones, right? To strengthen up your bones, you store calcium and phosphates, and it strengthens up the bones, and that's what we want. We want to store calcium there. So if blood calcium levels go up, wouldn't it be nice to put our calcium into our bones? And if your blood calcium levels are going down, wouldn't it be nice to take the calcium out of the bank, which are the bones, and put it into the blood? So that's basically what we're going to be doing. Now, the first most important part is what happens if blood calcium levels drop. This is not a part of your answer, what I'm going to tell you here. Blood calcium levels are super important for a variety of reasons, but the first one is proper functioning of the nervous system. Functioning of the nervous system. If you have too little blood calcium, then you're going to have problems. If you have hypocalcemia or hypercalcemia, you'll have problems with your nervous system, and also the muscular system is the same way. And if we don't have enough blood calcium, it's going to be, we'll find out, well, yeah, we'll find out in the next chapter that calcium is a procoagulant. So we can't properly clot if we don't have the right amount of calcium. So blood clotting. So do you see? You know that blood clotting is going to be important so you don't bleed out. The nervous system is incredibly important, and the muscular system is incredibly important. So we want to make sure our blood calcium levels don't drop. So we're going to start off and we're going to say, the dog is big dog. Okay. Blood calcium levels drop. Now, I always put these two pluses up here because that's an ion. Remember, it will carry a charge in a solution, but it's lost 2 electrons, and then that's why we do that. So blood calcium levels drop. So what do we do? Do we crave cheese? No. What's going to happen is our blood calcium levels drop, and we have an endocrine organ that's going to figure out that that's happening. And very specifically, that's going to be the parathyroid gland. So the parathyroid gland is our major blood calcium controller. So what the parathyroid gland does is it detects and it releases parathyroid hormone. Releases PTH, parathormone, or most people just call it parathyroid hormone. I'm getting better with my writing, I think. Okay, now the parathyroid glands, like, oh no, blood calcium levels are dropping. Release the hounds, which would be parathyroid hormone. And what parathyroid hormone is, because it's a hormone, it's going to go to its target organs, and it's going to target 3 different organs. PTH is going to target the bones. We'll put A here. It's going to target the intestines. Wow, that was magic. Intestines. And it's going to target the kidneys. Now, the reason it's very specific why it's targeting these three organs. Well, first of all, we're storing calcium in our bones. And so how do we get calcium out of the bones? You go to those cells in the bone that can literally dissolve the bone and release calcium back into the blood. So if we're calcium in the bone, we're not in the blood, right? We want to get the calcium out of the bone, put it into the blood. So very specifically, PTH activates osteoclast. If you can remember about osteoclast from last semester, osteoclasts are the bone crunchers or the bone dissolvers. So that right away is going to increase blood calcium levels. And in the intestines, what PTH will do in the small intestines, this you don't know because we've not done the digestive system yet. But when we eat and food goes through our body, when it gets to the small intestines, that's where most nutrient absorption occurs. Like food in your stomach, the nutrients aren't absorbed into the blood there. It has to get to the small intestines. That's our major site of nutrient absorption. And so when calcium is in the small intestines, it can go through, you can put calcium, a lot of cheese in your mouth, and the calcium can go all the way through, out the other end. If you don't need calcium, you can release calcium in a variety of ways, including in urine, and you can get rid of calcium in your feces. But PTH, what it does to the intestines is it tells the intestines, hey, we need as much calcium. Please harvest as much calcium from our food as you can. So it tells the intestines to absorb more calcium from food. Now, here's the thing about absorbing calcium for food. We need vitamin D to absorb calcium. That's why you always see milk jugs with vitamin D fortified. That's why if you're trying to buy calcium supplements, it's always going to have vitamin D in it. It's kind of maddening if you have too much vitamin D already to try to find just a pure calcium, but you cannot, pure calcium supplement. You can't absorb calcium without the help from vitamin D. So that's where the kidneys come in. Now, cholesterol is how we make vitamin D. Cholesterol goes, as it goes to our skin cells and light hits the skin cells will make an inactivated form of vitamin D. And that inactive form, when it is going through the blood, the kidneys, with the help of PTH, if PTH is there, the kidneys will activate that inactive vitamin D to make it possible for your intestines to absorb the calcium. So, kidney activates vitamin D because the type we make in our skin is inactive. And this helps us absorb more calcium. So straight up, our blood calcium levels are going to increase. Something was going down, the body took steps to make it go back up. That's negative feedback regulation. This is the main way that we control our blood calcium levels. This is the main way. The next way that I'm going to talk to you about, I'm only mentioning it because we do produce this hormone, and what it does is it decreases blood calcium levels, but we have a variety of ways that we can decrease blood calcium levels. We take in the calcium, we put it into our bones. If we don't need it, we don't absorb it from our food, and we release it through the feces or the urine, etc. But in children, this is more important than in adults. If you have high blood calcium levels, your blood calcium levels are increasing. Now, I'm going to make it seem like this happens in you and me and etc., but we're adults. It's not really going to be like this. But the reason I teach this is because you might come into a time in your career when someone has high blood calcium levels and you treat them with a hormone to bring their blood calcium levels back down. And so this has therapeutic reasons, let's put it that way. Blood calcium levels go up. In this case, it's not our parathyroid gland that detects. It is the thyroid gland. Remember, those are two different organs. When it detects this, the thyroid gland detects and releases not thyroid hormone, but it releases calcitonin. It tones down calcium levels, tones it down. Okay, so your blood calcium levels went up. The thyroid detects and releases calcitonin. And so one place where we could put calcium is in the bone, so it's going to activate different bone cells. Calcitonin targets your osteoblasts to make more bone. Calcitonin targets osteoblast. And we're going to put, that puts the calcium in, there's a delay, in the bone. And what's going to happen is if we're taking calcium out of the blood and putting it into the bone, we're automatically decreasing blood calcium levels because calcium cannot be in two places at one time. There you go. That's negative feedback regulation of blood calcium levels. And this is not part of your answer, but if you're like, why do I care about calcium? Everybody should care about calcium. If you don't have proper levels, too much or too low, this is the term for too little blood calcium, hypo, meaning less than, calc for calcium, emia for blood. If you have too much, it is hypercalcemia. There you go. If you have too much, usually that's because you might have something like hyperparathyroidism, and your parathyroid gland is releasing too much PTH, and the PTH is telling your osteoclast that targeting the bones, the intestines, and the kidneys, and you have too much calcium because of you have a parathyroid gland that's rogue. That could be one reason. Another reason is oftentimes if you have a malignant cancer, you can have hypercalcemia. For any reasons. If you have hypocalcemia, if you have too low calcium, and by the way, this resembles your nervous system is delayed. For instance, you don't have the nice reflexes, and you're tired, fatigued, etc. If you have hypocalcemia, then that's going to be much more of a problem. If you have dropping calcium levels, then your nervous system and muscular system will be really acting up, and that could lead to death. Okay. Should have stopped talking 5 minutes ago.